dogs, welcome to multiple choice 7. So it looks ominous because we've got a word problem and it looks like I'm going to have some exponential growth. I say that because I can see this base E here. Part of the upside to this problem is at least they're giving me a starting formula, but I do have a lot of variables here I'm going to have to parse out. So let's read through this and see if we can be on the listen for any of these variables that are going through here. So it says, after sitting out of the refrigerator for a while, a turkey at room temperature, 68 degrees Fahrenheit, is placed in an oven at 8 a.m. when the oven temperature is 325 degrees Fahrenheit. So before I even get going, I see that I've got I would say a pretty cold turkey that's going to get placed into a semi-warm oven. So it's going to heat up. All right, Newton's law of heating explains that the temperature of the turkey will increase proportionally to the difference between the temperature of the turkey and the temperature of the oven given by this formula. So you can see there's the difference between the temperature of the turkey, right, T sub O, and the temperature of the surrounding air, right, or the temperature surrounding the object. All right, looks like little t is time in hours, capital T is the temperature after T of those hours, and K is the decay constant. So as I'm starting to float through here, and I haven't gotten to the setup yet, but I can hear that T sub A, the temperature surrounding the turkey, is 325 degrees Fahrenheit, right? I can also hear that the temperature of the turkey itself was 68 degrees Fahrenheit. So I can hear a couple of these things just as I'm going through this, all right? So let's see what this next part adds to it. So it says the turkey reaches the temperature of approximately 100 degrees after 2 hours. So this is a T time and this is a T time. So capital T, little t. I can hear that ordered pair of 2, 100. After 2 hours, it was 100 degrees. So in that 2 hours, it heated up from 68 to 100 degrees. Determine the Fahrenheit temperature of the turkey to the nearest degree at 3 p.m. Okay, so let's figure all of this out. So if I want to get going, I'm going to need to figure out what T sub A is, which we know, T sub 0 minus T sub A, which we also know, but I need to figure out this K here. If I can figure out that, I'll have my exponential model, right? So I don't know what the K is right now. We'll get that in a moment. And then if I want the temperature at 3 p.m., all right, and think about this, T is time in hours. Well, if this started at 8 a.m., right, we go 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3. So it's 7 hours later. So 3 p.m. is 7 hours after 8 a.m. So let me write this. 3 p.m. is 7 hours after 8 a.m., which is telling me I'm really ultimately going to be looking for when little t is 7. So I know this number, I'm going to subtract these two numbers, I'm going to find K in a moment, and then eventually I'm going to plug in T equaling 7, and I'll find out the temperature of the object after 7 hours. All right, but let's use this ordered pair and start kind of plugging away at all of these variables. So at this point, I know capital T is equal to 325 T sub A plus, and it looks like I need to subtract T sub O minus T sub A plus 68 minus 325 e to the kt. All right, and if I subtract this number, this is going to be minus 257. So this is going to be 325 minus 257, and you can just put into your calculator 68 minus 325 e to the kt. I'm beginning to get my exponential model, but I do need to figure out what k is equal to. But they gave us this ordered pair. They said, they said the temperature is 100 degrees after 2 hours. So I'm going to put 100 here. I'm going to put 2 in for t, and that's going to allow me to solve for k. So let's do that. I'm going to put 100 here. I'm going to put in 2 for t, and that's going to allow me, again, to solve for t. Now I'm going to scooch this up. We're going to lose some of this information, but I just want you to remember that when we get going, we're going to let little t equal 7. But let me move this up so that I have some room to write the rest of this problem out. Okay, if I want to get to k, and I'm eventually going to write this as just 2k, the first thing I'm going to do is subtract 325. So I'm going to subtract 325 from both sides because I have an exponential equation. My variable is up in the exponent. I'm eventually going to need a logarithm. So I'm going to have negative 225 is going to be equal to negative 257 e to the 2k. I'm going to divide both sides by negative 257. So let me divide this by negative 257, this side by negative 257. And these are going to cancel. I'm going to actually write this on the left side of my equation. I like to have the variable I'm solving for on the left side. It's going to be equal to 225 over 257, whatever that number is equal to. I'll put that into my calculator in a little bit. But my variable is up in this exponent, so I need to log both sides. And since this power here, this is an exponential term with base e, I'm going to opt to do the natural log. So I'm going to do the natural log of both sides, right? And then ln and e cancel by design. So that's going to let me know that 2k is equal to the natural log of 225 over 257. All right, whatever this number is equal to. I don't know what it's equal to right now. I'm going to crunch it on my calculator. But to get KL by itself, what I really need to do, and let me scooch this up just a bit more so we can see what my next line will be. If I really want to get to K, the last thing I need to do is divide both sides by 2. Right? So K is actually this giant beast of an expression divided by 2. And let me get to my calculator now. I've got it over here. Let me go ahead and let's see what K is equal to so we can get a number around this. So I'm going to do, and I think we can see, yeah, natural log of 225 divided by 257. And I need to divide that by 2. So when I crunch that, I get negative 0.66. Oh, excuse me, negative 0.066. So let me go ahead and write that down just so I have it. So here, K is going to be equal to negative 0.066. Okay, so now let me go ahead and substitute that into my exponential model. So I know temperature is 325 minus 257 e to the negative 0.066 t. And so now that I have my exponential model, if you give me a time value, the number of hours that this turkey has been out, I can tell you its T value, its temperature. And keep in mind, we're looking for 7 hours after 8 a.m. So what I'm going to do is I'm going to plug in 7 right here for little t. So 325 minus 257 e to the negative 0.066 times 7. Keeping in mind, I might have a slight round off error. I'm going to have to see what answer I am closest to. And this is just going to be a plug in my calculator sitch. So I'm going to do 325 minus 257 e to the negative 0.066 times 7. And when I crunch this, I'm just going to see what my temperature is. So if I look at that, that's about 163 degrees. And let me write this out. This is 163.084, and the units are degrees in Fahrenheit. And when I look at my numerical answer in reference to the options in A through D, D is closest. All right, thanks so much, everyone. Bye.